Today we are doing 2.1 relations and functions. So this whole relation thing, I used to never even teach it. All it is a set of ordered pairs. So the only difference between a relation and a function is that in a function, x values can't repeat. In a relation, they're just random values. X, y values, ordered pairs, as shown here. Right, so if you look at the ordered pair right here, the 4's repeat, so that would not be a function, but it is a relation. So with both relations and functions, you can represent them in all four of these ways they show below here. You don't have to write all this stuff down. It's just like for your information kind of thing. Now, mapping diagram. So if you look right here, let me just erase my little highlights. If you look right here, 3, -3 is right there. This is how you make a mapping diagram. The 4, you just draw an arrow over to the 4. Okay, you got +3 right there to -1 right there. Okay, so that's all you have to do with the mapping diagram. The ones that I'm going to care about are going to be a function. With a function, you always list least to greatest, no repeats, which we'll say again in a sec here. Another representation of a relation is this dude skydiving. Anybody been skydiving? Nobody all day long has been skydiving. That's 85 of you have never skydived. I haven't either. Anybody bungee jumped? We talked about that, I think. Yeah. Okay. Well, whatever. You normally, when you jump out of a plane, start at 10,000 feet. That's kind of the normal. You're learning how to skydive kind of thing. And then you can see the ordered pairs right here for the skydive. Right? So that's just another representation. You can make the mapping diagram, a table, and a graph. Alright, now this is where it starts to matter. We're going to find the domain and range of not a relation, but a function. This is where like the stuff's going to be on your quiz tomorrow begins, so focus up. So that's not correct, because that was not in least to greatest order. So if we look at the reds, they're already in order, right? 0, 4, 8, 12, 16, 0, 4, 8, 12, 16, like that. So when we list the range for this, the y values, well, with this one you just go backwards. So 59, so actually let's just list the range, why not? So range would be 5904, 76, 96, 89, 76, and 97, 44, and then 10,000. Right? So remember, you guys, domain is x, range is y. If you just, this is how to remember which is which. X and y are always alphabetical order. Domain and range are also alphabetical order. So then I don't even have to think about it. Domain's x, range is y. So, least to greatest, no repeats. You'll notice I wrote that helpful hint and then double underlined it. That's how many times I see students make that mistake. They won't either list at least to greatest, or I'll give them a set of ordered pairs where the y values, let's say they're all -6 or something like that, and the kids will list -6, comma, -6, comma, -6, comma. Like, don't do that. You only write -6 one time. Okay? So least to greatest, no repeats. Star that, like highlight it, do whatever the heck you got to do to understand that's how it's going to go. Okay? Excellent. So you can see there are 12 slides, but it goes pretty quick. So domain and range of the function. I have no idea why this textbook makes such a big deal out of the relation, because you literally will never talk about that again. So you're looking for domain and range. So all I do is just make big fat capital D for domain, and then list them off, least to greatest, no repeats. So there are no repeats, so it is a function, and they're already listed in that least to greatest order. So -3, 0, 2, 9, 23. Boom. Okay, range is just backwards, right? So -99, -18, 0, 7, and 14. Okay, if you're not taking notes, you should be taking notes. I can tell there's a few on this that are not taking notes. Take notes. Michael, turn your camera on, please. Okay, so that's it. Just least to greatest, no repeats. It should be pretty easy. So a function is, read that top sentence. Just take a moment and read that, and then we'll talk about what the heck it means. So it says a function is a relation in which each element of the domain corresponds with exactly one element of the range. So I just really encourage you guys to start reading that kind of statement and trying to understand it, because it's very SAT-like in nature. You're going to have to decipher that kind of math language, so just be ready for that. So what that means is it's a function as long as there are no repeated x's. I'm going to write that down. So it's a function when x values don't repeat. So one of the questions on your quiz is going to look similar to A right there, problem 3A. We're determining if that set of ordered pairs is a function or not. So all you have to do when you're looking at one of these mapping diagrams like this right here, all you got to do is look, and if two arrows come from the same domain value, it is not a function. If you have one arrow coming from each x value or domain value, it is a function. So if you just want to go even further with it, we've got -3, -2, one ordered pair. We have 0, 7 as a second ordered pair. The last one is 4, 1. And we just look at those x values. Do they repeat? Nope. So yes, it is a function. Now, when we look at the set of ordered pairs over here, the 4's repeat, so it is not a function. Okay, if I make a mapping diagram with that, I told you you're going to have some kind of mapping diagram question on your quiz. I'm just not telling you if it goes from ordered pairs to the mapping diagram or vice versa. So you just got to be ready for both possibilities. So I'm going to make a mapping diagram out of this set of ordered pairs just so you can see how it works. So for a mapping diagram, all you do is connect x values with corresponding y values. So mapping diagram. So I'm going to list domain and range first. I'm going to list it vertically as opposed to horizontally. And then we can make our mapping diagram. So when you list the domain values, as always, list it least to greatest, no repeats. So our smallest x value is 1, 4, 6, and 8. The 4 repeats, but you only write it one time. So 1, 4, 6, and 8 like that. And then the y values go -1. Next biggest one is 1, and then 6. So so you look for 4, and draw your arrow to -1 to take care of that first order pair. Second order pair is 8, 6. So just draw an arrow between those two numbers. Third order pair is 1, -1. Fourth order pair is 6, 6. And last one is 4, 1. So right here, because you've got two arrows coming from that 4, that's what makes it not a function. Okay, so that's how you make a mapping diagram. You may have to go from ordered pairs to the mapping diagram or vice versa, as I said before. Okay, so 3A, thumbs up function, thumbs down not. Thumbs up function, thumbs down not. Just looking around, seeing who's participating. Some people are not. Say, oh, you're not participating. Yes, it is not a function because we have two arrows coming from 2. Right? So we have an arrow here and an arrow here, so that is not a function. So if I look at B, function thumb up, not function thumb down. So all you're doing is looking for repeated x's. If you have a repeated x's, it is not a function. If there are no repeated x's, it is a function. So thumbs up function, thumbs down not. So I look at my x values, I have -7, 9, 14, and 7. So yes, this is a function. Okay? Simple as that. So you'll have questions like this on your quiz. You'll be able to do them pretty darn fast. So take a sec, read that the top paragraph there about the vertical line test, and then we'll talk about it. So what we do with that vertical line test is we take a vertical line, pass it over the function. If it hits the function twice, or I should say if it hits the relation twice, it is not a function. Okay? So if I just look, the reason I wrote those random numbers there is I just want to show you what the order pairs look like. So this order pair right here would be 3, 3. The top order pair right here would be 3, 6. So because those 3's repeat, that would not be a function, right? No repeated x's allowed. So that's how the vertical line test goes. We're going to do a couple more with this. You don't have to write them all down. You might want to write an example or two. But if you get vertical line test, then that's good. So A, function, thumbs up, not a function, thumbs down. You're just seeing if it hits it twice. Good, 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 good. So we hit it here and here, so that's a nope. B, function or not, thumbs up, thumbs down. Yeah, I saw that. Melody's like, crap, I don't know. Right, so if you pass that vertical line, right, so there's one vertical line. Did it hit it one time? Yes. So it looks like function. Here's another vertical line. It only hit it once. The red dotted line only hit it once. So because we can pass that vertical line all the way across that function and only hit it once, that's why, yep, it is a function. The last one, because we hit with this vertical line those two dots, those two order pairs, it's a note. Okay? So pretty easy, right? How about this one? A, thumbs up, thumbs down, function or not? Melody, come on. There you go. Yeah, because it hits it twice, right? If we draw a vertical line, can we hit the function twice? Yes, we can, so it is not a function. B, you can draw vertical lines everywhere through all those ordered pairs. You only hit the ordered pairs once, so that relation is a function. And the last one, that's a cubic graph. Could be a sine curve as well, but that also is a function, because if you draw a vertical line, you only hit it once, so that's why it is a function, right? That first one hits twice. This one, you only hit once wherever you draw that vertical line. That's why that one is a function. Okay, we're already on 9 out of 12 slides. So every class today has finished their homework. Some people with like 30 minutes left in class, and you guys can peace out as soon as you turn in your homework. Totally good. All right, read. Just take a look at this slide. I'll give you a minute or two. Read and try to digest that information. All right, so it says function rule is an equation that represents an output value in terms of an input value. That's where like half of you stop paying attention in that first sentence, right? You can write a function rule in function notation. Shown below are examples of function rules. So output is the y value, input is the x value. Input is independent variable, output is dependent variable. Okay? Because depending what x value you choose, that influences what the y value will be. So that's why the y value depends on the x value you choose. So when I took college algebra to get ready to, I just wanted to take it before I took calculus so I could relearn my algebra when I wanted to become a math teacher. Nobody told me that those two things are the same, right? They're not exactly the same, but you can use them interchangeably. So this is read right here as f of x, right? Just like they said right here, f of x. Okay, if we plug in the 1 like they did here, you read it as f of 1. So all that means is, if I plug in a 1 into the equation, what do I get? My input is 1, what's my output? My independent variable is 1, what is my dependent variable? Okay, so that's all they're talking about there. So my issue is that when I took that college algebra class, so if we just look at this last equation right here, f of 1 equals 3 times 1 plus 2. Nobody told me you could not do math on the f of 1 side. You can't do math. So right here, that side, no math allowed. All that's saying is what happens when you plug in 1. So I was trying to do math on that left side of where the f of 1 side, and it just ruined about a week of my life. It cost me about 20 hours of time to get that. It was so long ago, it was kind of at the very beginning of YouTube, so I couldn't even look anything up and be like, what is going on? I don't get it. Now you guys have it way easier. Between Khan Academy and YouTube, you can get anything you want. Okay, so that's function notation. F of x basically means the same thing as y, just saying when you plug an x value in, what do you get? What's the answer? All right, take a sec and write down, I would just draw the chart. The only thing I'm going to change is this last column, because I like it when you guys write these as order pairs. And we'll always do that last column when we do these charts, because we'll do them a couple of times during the year as we get to different topics and stuff. We'll always have that third column be x comma y. So all we're doing is plugging this -3 in for this x and that x. So it's just asking you what happens when you plug in -3. So you get f of -3 equals -2 times -3 plus 5. -2 times -3 is 6. 6 plus 5 is 11. So when I plug in -3, f of -3 equals positive 11. So when you write that ordered pair, you just have -3, 11. When we plug in 0, what do we get? Show me with your hands. Do it in your head. Should be easy, no problem. You got it, you got it, you got it. No, you don't get 0. You get 0 for part of it. You get 5. I'm trying to figure out how I can turn my hand so I can see it better. You get 5, right? Because this part's going to cancel when you plug a 0 in, and all you have left is 5. So f of 0 equals -2 times 0 plus 5. F of 0 equals 0 plus 5, which obviously just equals 5. So our ordered pair is 0, comma 5. So if you think about y equals mx plus b, because this equation is in y equals mx plus b form, what does 0, 5 represent? What part of y equals mx plus b does it represent? The y what? What does that be in y equals mx plus b? Every single one of you should know that.
Y-intercept.
Y-intercept, good. Right? So it's just a y-intercept, that's it. When you graph lines, you start at the y-intercept and then you do the rise over run of the slope. In this problem, you would go down to right 1 for the slope. So you start at positive 5, go down to right 1, bam, you got the graph. 1 over 4 is, when you divide it, you get 0.25. 0.25 is a terminating decimal, so it means it stops at the 5. It's not like 1 over 3, which is 0.3 repeating. So when you have a terminating decimal, I would always use a decimal instead of a fraction because it's easier. So, oops, that's not what I meant to do. So we have f of 0.25 equals -2 times 0.25 plus 5. So what, I want you to think in your head, what is -2 times 0.25? So stating it, as soon as you know, raise your hand, just so I can, and I'll kind of talk you through it as we go. So we're doing -2 times 0.25. Think of what's 1/4 of 2. If you know what it is, raise your hand. Keep your hand up. If you need to go to the gym, you might need to hold your elbow up like that, especially if your name's Garrett. He needs to hit the gym pretty quick here. So 0.25, what's 1/4 of 2? 25% of 2, 0.5, so -0.5. Raise your hand if you got it correct. All right, good. So think about that stuff in your head frequently. It just helps you. So our order pair then is 1/4. You could have written 0.25. That's fine too. And so we got -5 minus 0.5 is 4.5. So when you have your calculator, what I'd recommend is doing that in your calculator. You could go like 0.25. I did it in the wrong order, but it doesn't matter. So 0.25 times 2 plus 5, right? Or it's supposed to be negative. My bad. So here's another thing in your graphing calculator. If I need to insert that negative, because sometimes you put in these big, huge, long mathematical equations, and you don't want to have to rewrite the whole thing, I can hit second. You can see on my calculator, because the button turned red, right above delete it says insert, and I can then insert a negative, like that, and then bam, I got the correct answer, 4.5. So one thing I want to point out to you guys is that, so I just hit negative first and then the minus subtraction sign. So if you have a negative like at the beginning of a problem, like negative 2x squared plus 4x minus 8, see how the negative is smaller and it's raised up a little bit? The next sign is a minus sign, right? So when it's a negative, you got to use a negative. Moral of that story. All right. Last one. You have a problem very, very similar to this on your quiz tomorrow. So when you take that quiz tomorrow, we'll review for a little bit. I'll remind you of a few things. You take your quiz. As soon as you're done with your quiz, you can leave. Right? If it takes you the whole hour and 20 minutes to finish the quiz, that's fine. But as soon as you're done, if you finish it in 5 minutes and you're done, you get 100, turn in your work, it's all good. Peace out. So, story problem method. First step is read, don't write. Tickets to a concert are available online for $35 each, plus a handling fee of $250. The total cost is a function of the number of tickets bought. What function models the cost of the concert tickets? Evaluate the function for 4 tickets. So now we read and highlight. First step, read, don't write. Second step, read and highlight. So when you see like 35 each, that means that's where the variable goes. So whatever they're talking about with the 35, that's going to be your variable. Then we have a handling fee. This is what you're writing down in your notes. Handling fee of $250. We want to know the total cost as a function of tickets bought. Right? So cost of tickets, that's what that thing means down there. C of T, cost of tickets. What function rule models the cost of tickets? Then we're just going to plug in 4. Okay, so I'll give you a sec to write that down. If you think you can write the equation, write the equation because it's good practice for tomorrow when you take your quiz. This is the last slide. So, we have the formula is going to be C of T. So when you write this equation tomorrow for your quiz, you have to use function notation. You can't say Y here, right? They're probably going to be talking about cost again. I made the quiz a couple of days ago, so I don't remember if it's cost or, but it's probably cost of something. So C of some other letter. So each ticket costs $35, so you get 35T. One-time handling fee of $250, so you just add 250, 2.50. You don't have to have the O even. That's your equation. So we're going to take this 4. It says evaluate the function for 4 tickets. We're going to take that 4 and plug it in right here and right there to see what we get. So we have C of 4 equals 35 times 4 plus 2.50. Do 35 times 4 in your head. Raise your actual hand once you're done. 35 times 4 in your head. See how fast you can do the mental math. That was pretty fast, so Garrett's got it. Nice, Haley. 35 times 4 in your head. So if you're struggling to do that in your head, good job, Michaela. Think of 30 times 4 and then 5 times 4 and add it up. Right? So 30 times 4, buck 20. 5 times 4, 20. Add those two, you get 140. Okay, every single one of you can do that. I used to teach a basic algebra class. Every single one of those kids could do it. And those are kids that massively struggle in math, but they could do it too, so you can as well. So we get 140 right here. So the cost of 4 tickets is 140 plus the one-time handling fee of 250. 140 and 250 is 142.50. So the cost of 4 tickets equals $142.50. Make sure when you show me your work tomorrow, you remember units. I have not taken points off for units. I will on tomorrow's quiz if you don't have units. Right, the correct answer you select on Schoology is worth 1 point. The work you show is the additional 3 points. Now, if I give you a problem where you're just doing vertical line tests, you can't show any work. So it's kind of an all or nothing question, but you must show work wherever you can. I think on this quiz, there's 6 questions, and you did not need to show work on 3 of those 6 questions. The rest of them you do need to show work. So I imagine if you know what's going on in this class and you've been doing all your homework and stuff, you could probably finish this quiz. I mean, it took me 7 minutes, 10 minutes, 15 minutes, something like that. But don't rush. Take your time. You have plenty of time. Remember, I did it. I took 7 minutes, so I take the time it took me times 6, and that's how much time I give you. So you have 42 minutes to finish this quiz. So remember, you can only view 1 question at a time. So you got to make sure you get that question, and you can't go back. Okay, so make sure you got it dialed before you submit, before you move on to the next question. Any questions about this? Sweet. All right, I'm going to stop the recording. Homework is posted